Chapter 9: Introduction to Metropolitan Area Networks and Wide Area Networks. Introduction to MANs and WANs. MANs is the medium-sized, WANs are the large size, LANs are the small size that we covered already. Here are the objectives of this chapter. And Metropolitan Area Network is a network that expands into a metropolitan area and exhibits a higher data rates, higher reliability, and low data loss is called MAN. And we'll move forward. Basics about MANs. Let's talk about characteristics. The first characteristic about the MAN is that MANs cover much greater distances than LAN do. It's wider area, larger area. Second characteristic that distinguishes MANs from LANs, but not necessarily from WANs, is that most MANs can recover very quickly from a link or switch router failure. If there is a failure, the MAN can recover much faster than the LAN. All right. And this is called the failover and failover time terms. And this is a physical ring used to support MAN, physical ring, logically and physically. All right. So we have redundancy more than a path. And if we move forward, okay. Now we talked about the two characteristics. A third characteristic that distinguishes MANs from both LANs and WANs is that some MAN topologies are based on a ring. This is the third characteristic. The fourth characteristic and the last a feature that beginning to appear in a MAN but neither in LANs nor WANs currently have is the ability of a user to dynamically allocate more bandwidth, dynamic allocation of bandwidth on demand. All right. So these are the four characteristics that distinguishes MANs from LANs and WANs. And we have two basic forms. Almost all MANs are based on one of two basic forms of supporting technology, either SONET or Ethernet. And this is called Metro Ethernet because the Ethernet is used in LANs. And now they start to be used in MANs as well. So we have the Ethernet is used in the metropolitan area networks, and we have the SONET. All right. So the SONET is the ring, a big ring. Each one is a small ring. So it's a ring of rings. All right. And if we move forward, this is the mesh technology of an Ethernet MAN. It's called Metro Ethernet. Ethernet is cheaper than SONET, and it's well known. So the competition is really high. Two point-to-point connections. So we have point-to-point connection, and we have multi-point to multi-point connection, just like that. So we have two types of connections. And bandwidth profile, a company that has a connection with Metro Ethernet can create bandwidth profile for that connection. All right. Wide area network basics of WANs. A wide area network is a collection of computers and computer-related equipment interconnected to perform a given function or functions, typically using local and long-distance telecommunication systems. Local and long distance. It covers a large area and can be used in manufacturing, medicine, navigation, education, entertainment, telecommunication, and much more. So basically, the cell phone system, the mobile technology, using wide area network. A simple mesh network, just like this, so you have more than a path to reach the destination. Each one of these circles is called a node, and here's the definition of the node. And we can have subnet or a network cloud. The subnet or network cloud is a collection of nodes and interconnecting telecommunication links. So the thing that connects the two nodes, they call it links. And each link has a weight. It depends if it takes longer time or it takes shorter time. It can be longer in physical distance, but the weight is low because it uses fiber optics and it's very fast. So it's really, the weight depends on the speed more than the distance, the length. Types of network clouds: circuit switched and packet switched. Circuit switched is the thing that establishes a physical link, physical connection. And it was used in the analog systems before. And I think it's obsolete. Nobody's using it anymore. And the packet switched is the current thing that when the digital world, when the world became digital, everything became in packets, and even the voice became voice over IP. So that's a packet. And the packet switch network can be either datagram or virtual circuit. Virtual circuit is just like it's a packet switch, but all packets that belongs to a logical connection can follow the same path throughout the network. So it's like a logical virtual circuit. But the datagram, that in a datagram network, each data packet can follow its own possibly unique course through the cloud. So it has its own path. The packet is addressed, then sent. It might go in this way or that way, depends on the availability of resources. All right. Broadcast networks. As in the case of a node that broadcasts the design of most local area networks, when a node on a wide area network broadcast network transmits its data, the data is received by all other nodes. So broadcast networks, just like the radio station, is not really used that much. Everything is addressed now. And this is also a type. So we have the circuit switched, we have the datagram packet switched, we have the virtual circuit packet switched, and we have the broadcast, and here's a comparison between them. Connection-oriented versus connection-less. Connection-oriented ensure no data is lost. Connection-less, data might get lost. So the connection-oriented provide a reliable service. Connection-less does not provide a reliable service. Each one has its own usage, though. I mean, all right. One of the common examples of connectionless network example is DNS, a program or a server that converts a URL such as www.something into an IP address. It's just like the telephone book in the old days. We used to have telephone books. The DNS is just like that. So you have the name, it gives you the number. And here you give the URL, it gives you the IP address. All right. Connection-oriented telephone call, just like this. Connectionless postal network, just like this. Routing. So as we can see from this 7-node network, so this is A, B, C, D, E, F, G. That's 7 nodes. So from A to G, we have many paths, either through A and D and G, or through A and C and F and G, or through A and B and E and G, or through A and B and E, then D, then G. So each one is really has its own path. So we give the nodes numbers or names, then we give the ages or these paths or links that connect the nodes weights, depending on how long it takes to transmit and receive. So basically, if we follow the length of the the link between the nodes, it means we are using the same medium. Like here, we use all Cat6, for example, or we use all fiber optics. So we follow the length, one criteria. Or we use all wireless. By the way, wireless medium has different challenges because it has the scattering, the reflection, the refraction, the echo, the other challenges. So each medium has its own challenges. Let's keep going on. We are talking about what? About the routing, all right? So we gave the nodes names and then we give the links that connect the nodes, we give them weights, all right? And we have Dijkstra's least cost algorithm. So it follows the minimum weight in the path. So this is one of the algorithms. It has weights, then it follows the weights, okay? Network with costs associated with each link. The cost associated with each link. Sometimes it's the weight is related to the money or the speed or something else or combination of both. All right. Flooding, just like when the water fills something and cause a flooding. If this is one of the routing methods, like every single node transmit in all directions. The receiving node, for example, C, transmit in all directions except the source, and so on. And this cause something called hop count and hop limit to prevent the packet from keep circulating forever. So we have the hop limit and the hop count. We start counting. This counter is called the hop count. A network limit called hop limit can be placed on how many times any packet is copied. All right, we are talking about routing. So now we have centralized versus distributed routing. Centralized, we have a central point. Distributed, we don't really have a central point. So if we have a centralized, we have a routing table at the centralized network side, and it's just like this. And the local routing table for node C, for example, each node has its own local routing table. All right. And here we have routing information protocol, RIP. This is not rest in peace. This is routing information protocol, RIP. Okay. And this details section shows how it does work, how it works. So if I zoom down, so it shows the full thing. That's the full thing. If you want to take a screenshot and go through every single word here, it's very useful. I'm skimming the book, so I'm not gonna really pay attention much to the details. I'm giving you a rough idea of what's going on in this book and the book title. You can search it, it's available. Adaptive versus fixed routing. Adaptive routing is the dynamic that keeps updating the nodes, the weights, and everything. Depends on the failure, depends on network expansion, depends on whatever. And the fixed does not do that. It just fixed. It does not update itself. And here we have in the details section something called OSPF. OSPF is mentioned or explained in the next page. It's called Open Shortest Path First protocol. So it goes for the shortest path first. All right. And here's details about Open Shortest Path First. In order for Open Shortest Path First to handle routing in an efficient manner, a system or a network collection of network is divided into areas. An area, like when you try to rule a country, you divide it into cities and the city into neighborhoods or counties. So it's always subdividing the thing makes it easy to handle, right? So the same with networks, it's subdivided into areas. An area may be a collection of networks, routers, or hosts. All routers inside an area flood all other routers in the same area with their information. Special routers called area border routers interconnects two or more areas, and so on. All right. And we have a routing example here. Then we have the network congestion. Congestion is crowded, full of traffic. That's congestion. All right. When the network is saturated, they call it congested. All right. Problem associated with network congestion. And here is an explanation of what's going on and how things get filled with stuff and saturated, and the network buffers are full and insufficient buffer size. All right. Possible solutions to congestion. So we either deal with the congestion, two different categories. The first category contains solutions. So we have a congestion and we try to solve it. The other category is try to avoid the congestion from happening. So it's a preventive way. And preventing something from happening is better than dealing with it. But life is full of surprises, so you have to know both. All right. So the dealing with congestion is either by telling the senders to slow down and stop sending much, and this is called implicit congestion control, or explicit congestion control. It happens from outside, that when network signals transmitting stations to slow down, this is called explicit. So if something happened from the outside, that's explicit. If something happened from the inside, is implicit, to reduce the congestion. All right. With forward explicit congestion, so we have forward explicit congestion and backward explicit congestion, like who tells who. If it's from the with forward explicit congestion, when a frame relay router experiencing congestion, it sends, so the frame relay router, it sends a congestion signal forward to the destination station, which in turn tells the originating station to slow down. With backward, the frame relay router experiencing congestion sends a signal back to the originating station, then it slows down. So either directly sending to the original or through a forward, all right, through a middle person. And we have buffer pre-allocation. All right, so the second category is to prevent. One of the prevention things is to tell the network, I'm going to send this amount at this rate. So you announce your needs, all right? And we have the asynchronous transfer mode that we discussed, that we are going to discuss in chapter 11, approach network congestion in very serious fashion, because it transfer data at very high speed. Congestion can occur rather quickly and devastating. Thus, it's extremely important to keep congestion from occurring in the first place. ATM uses a congestion avoidance technique that appears to work quite well. The technique used to prevent or to avoid congestion in the asynchronous transfer mode is called connection admission control. Connection admission control avoids congestion by requiring users to negotiate with the network regarding how much traffic they will be sending. Right? So this is the way. Or what resources the network must provide to satisfy the user's needs before the user sends the data. The network cannot satisfy the user's demand, the user connection is denied. So it announces what it requires. And the question that the network expects from the user is this, all right? And many network related to this issue to the quality of service. So these things are now being addressed as a quality of service. So it's addressed as a congestion preventing in the ATM, or it's quality of service, all right? The same idea. And the quality of service released this SLAs, service level agreements, legally binding written document that can include service parameters offered by the service, various types of service support options, and of course penalties and incentives of if the service level are exceeded, and penalties if the service levels are not met. All right, rewards and penalties. And the smartphones are really WANs in actions, because the smartphone really uses packet switched, and basically it's a big metropolitan area network inside the cell. And this is the base station or the cell phone tower. All right. And here's the chapter summary, which is very nice and useful and handy. It's about the MANs, Metropolitan Area Network, and the WANs, the Wide Area Networks. And if we proceed to see the rest of the summary, and here's the rest of the summary, and rest of the summary and key terms. And we have the review questions, which are really nice. And I think the total review questions are 23 review questions. If you want to test your knowledge, of course, skimming a book is not a way to understand every single detail and being able to answer all these questions. But now you have an idea of what's going on in this book. Some people, they just want to take a quick look. They are not really interested to go through every single detail. And exercises page, and finally, this is also exercise page, and finally, thinking outside the box and hands-on projects. And see you in chapter 10.